Present work is based on the study of partial molar volumes and compressibilities of L-Arginine in aqueous solution of glucose or lactose at 37 degrees Celsius. I am Dr. Santosh Devsarkar from School of Chemical Sciences, SRTM University, Nanded. In the present study, we have tried to understand the hydration behavior of L-Arginine in presence of glucose or lactose in aqueous medium at 37 degrees Celsius. For this, the densities and ultrasonic velocities of the aqueous solutions of L-Arginine were measured in presence of glucose and lactose, and from these densities and ultrasonic velocities, the corresponding apparent molar volumes and compressibilities were calculated and were fitted to the plots to determine the partial molar properties and transfer properties. The dominating ion hydrophilic or hydrophilic interactions in the present systems are observed between solutes and co-solutes. In this presentation, we will see the apparent molar volume and compressibility, partial molar volume and transfer properties, co-solute effect on hydration behavior of L-Arginine, these properties and corresponding interactions in the solution, and conclusions. This is L-Arginine molecule, which is used as a solute, and this is glucose and this is lactose, which are used as a co-solutes in the present investigation. The apparent molar volume and apparent molar isentropic compressibility of the solutions were calculated by using the standard equation and by using the densities and ultrasonic velocities and molarities of the solution. The apparent molar volume and compressibilities were fitted to the least square method, and the plots were plotted between apparent molar volume and compressibilities of the solution with square root of molarity of the solution and corresponding partial molar properties, and the slope were determined. And from the partial molar volume and compressibility in aqueous solution and in aqueous solution of glucose or lactose, the corresponding transfer properties were determined. These are the results. It can be seen from the result that the partial molar volume increases with addition of the glucose or lactose in the solution. Therefore, as compared to water, these values are greater. Also, the SV values are positive, and transfer values of the transfer volume values are positive because of increase in the partial molar volume. Similarly, the partial molar isentropic compressibility, these are negative values which indicate strong solute-solvent interaction. SK values are positive, and the transfer compressibilities are again positive. The positive values of transfer compressibility as well as transfer volume clearly indicates the presence of hydrophilic type of interactions in the studied solution, because the negative values of transfer volume and compressibilities are corresponding to the hydrophobic interaction. Again, the values of SV and SK are positive. They are small but positive. This indicates weak solute-solute interaction, and positive and larger values of partial molar volume and negative values of partial molar isentropic compressibility indicate strong solute-solvent interactions. The transfer volume and transfer compressibility values are larger in lactose solution as compared to glucose solution. Here also it can be seen the partial molar compressibility values are also larger in lactose solution. This indicates the hydrophilic interactions are stronger in lactose solution as compared to the glucose solution. So therefore, this added glucose and lactose have strong effect on the hydration behavior of L-Arginine. There is a release of water molecules from the hydration cell of the L-Arginine, and there is an increase in the volume and compressibility. The solution becomes more compressible. Conclusions: strong solute-solvent interactions are confirmed, and extensive hydration of the L-Arginine is confirmed. Dominating ion hydrophilic or hydrophilic interactions in the solution. The glucose or lactose releases water molecule from the hydration cell of arginine. Lactose causes more dehydration of arginine than glucose. The study have implication in the hydration behavior of proteins. These are the references, and we would like to acknowledge the RGSTC, UGC and SRTM University for their support. Thank you.